This is as Michael said, the final webinar in a series of 3 webinars we've had. So today's webinar is, the title is Energising Community PV. And my name is Rebecca van Leeuwen, and I'm from the Netherlands agency, RVO, coordinating this EU Heroes project. So this morning we will have a number of presentations. So we'll start with one by myself regarding the overview and key findings of the project. And then we'll have several other presentations, followed by a coffee break. And then after the coffee break, we'll have the opportunity to have a discussion. And I'd really like to encourage you all to please take part in the discussion. I know it's a bit difficult with an online version, but as Michael said, we have the Q&A tab at the side of your screen. So please feel free to put your questions there and we will take those up during the discussion. Okay, so I think we'll move to my presentation. So first I'm going to explain a little bit about the main aim and activities of the project, about the partners, who I like to refer to as the EU heroes of the project, the work methodology, some key findings, and I'd like to provide you with some concluding remarks. Next slide, please. Okay, so the full title of the project is EU Routes for High Penetration of Solar PV into Local Networks. So a bit of a mouthful, which is why we chose for the acronym EU Heroes. And the project is a European funded project under the Horizon 2020 programme. And we started in September 2017 and we'll finish 31st of August this year. So we're actually nearly at the end of our project. It's gone very, very quickly for 3 years. So the project aims to enable increased deployment of community PV through new models and enabling grid integration. And the project aims to bring together all relevant stakeholders in the PV market. So the network operators, local initiators, energy specialists, citizens, policymakers, to develop robust business models and to create a win-win situation for everybody. Regarding the activities, include understanding the needs of the communities on the one hand and of the network operators on the other, developing new business models, and then piloting these business models. So it's all about empowering citizen engagement in the just transition to a cleaner and greener society. Next slide, please. Something regarding the partners. So there's seven organisations involved. So we have the Netherlands Enterprise Agency, RVO, and I'd also like to welcome my colleagues Otto Bans and Guido van Heemstra this morning. Welcome. From CRES in Greece, I'd like to welcome Vangelis and Tassos, Kiki and Elena. And also, I believe we have Vasilis Kilias. I'm sorry if I pronounced your name incorrectly, the former General Director of CRES, so we're very happy to have you here today. From Criera, from Spain, happy to welcome Andrea. From Dana, Germany. This morning, I'm happy that we have Pia Dorfinger from Dana, who was involved at the very beginning of the project. So welcome back, Pia. Nice to have you today. From Protect Lithuania, welcome to Vitas and Juras. And Karpa from Poland, welcome to Richard and Piotr. And from the Energy Saving Trust, the UK, welcome to Graham and to the whole team, so to Jack and Michael and Guy, Ewan, Paul, and I'm sorry if I've missed anybody, but welcome to all of you. And I'd just like to point out that this partnership was actually formed through the Renewable Energy Working Group of the European Energy Network, ENR, which some of you may be familiar with. This is a network of all the European energy agencies in and outside of the EU. And this year, the Netherlands Enterprise Agency is holding the presidency of this network. Next slide, please. Something regarding the work methodology. As those of you who've been involved in Horizon 2020 projects will recognise the terminology here, the work packages. So we divided the work into, well, the management and coordination, and then in the blue boxes on the sides, these are the cross-cutting work packages regarding stakeholder engagement, which is led by Dana, Germany, and the work package 6 is all to do with communication dissemination, which is led by the Energy Saving Trust in the UK. Then the work package 3, the case study monitoring performance data, is led by CRES, Greece. Then we have the work package 4, so the business model economic modelling tool, led by Creera in Spain. And last but not least, the work package 5 is the pilot projects. This is led by Protech Lithuania. Next slide, please. Without going into great detail, I'd just like to provide some information about each of the areas of the project to give you an idea of the whole project. So regarding the stakeholder engagement, the objective was to bring together the key actors from the energy community and the electricity network sectors and engage them in the whole project, engage them in delivering the objectives. And how have we done this? Well, we've had a number of activities, so seminars, bilateral working meetings, and thematic workshops. Next slide, please. Yeah, so regarding the thematic workshops, at each of our project meetings in each of the partner countries, we also had a workshop where we invited specialists from the field. And so the workshop we had in Athens in Greece, the main outcomes of that workshop were that we discovered there are caps on maximum of renewable energy installation and grid installation. There are high interest loans on financing. There aren't any incentives for microgrids. And we also discussed the economics of storage. And some solutions provided were that we could perhaps set up funds or grants for easier and cheaper finance conditions, or provide incentives reducing grid costs, for instance. We also had a workshop in Madrid, in Spain, where we heard all about the royalty decree, which has recently been introduced in Spain and sets the base for development of self-consumption. However, after discussion, we realised that the system is very complex and collective self-consumption needs to be specified. So there's kind of a mismatch of information in society. So a solution that was suggested was that we could perhaps have information campaigns regarding financial support of PV and self-consumption. Next slide, please. The workshop, which was actually the first one we had, was in Swansea in the UK. And here we talked about the lack of professionalised structures, access to land and buildings of financially viable projects, and organising permits, and also the legislation preventing increased deployment of community self-consumption. And some solutions we discussed were perhaps to have communal buildings opening up their roofs for community solar projects, and to create a framework that enables sites to directly connect to on-site users. And we also had a workshop in Lithuania at the Parliament building. It was a very big event combined with another workshop as well. And the concept of cooperatives or energy communities is widespread in Lithuania, but there's no political influence and there's a lack of finance mechanisms. So in Lithuania, they use multifamily houses to strengthen the concept of energy communities. And we discussed the idea of setting up financing mechanisms. And unfortunately, we never got to go to Poland. We were supposed to go in April, but due to the COVID-19, unfortunately, we had to do this online. So hopefully one day we will come to Poland, Piotr and Lisha. Regarding work package 3, the case studies led by CRES in Greece, We analysed a total of 11 PV projects, ranging from an installed capacity of 6.6 kilowatt peak to 1.6 megawatt peak. As you can see from the photos, some nice photos here of the case studies in the different countries, ranging from primary schools to an arts education, entertainment complex, passive house. Next slide, please. Next slide, yep. And we also produced a number of country reports, so 7 in total, giving a detailed technical description of each case study, together with the characteristic monthly performance data. And all these reports are available for download from our website. Next slide, please. Work package 4 was all about the business model development and training, led by Creera in Spain. So a financial model has been developed to evaluate different business models for the different case study projects. And in addition to conventional business models, the tool allows to test more innovative ones as well, such as the impact of batteries or demand side management. Next slide, please. Some features of the community solar tool. It's aimed at energy communities, business modelling. It can cover community scale. It includes battery storage, sensitivity analysis, and it's Excel based with a user guide. So it's quite easy to use, and it's available from our website. Next slide, please. Work package 5, the tool piloting and evaluation, led by Protech Lithuania, is all about demonstrating the benefits of the tools developed in the project to support community project developers and owners. And we've adapted model business cases, which were proposed during the Work Package 4, to real community and municipal solar projects. Next slide, please. And here you will see a list of the pilot projects identified. So for Greece, we have the Hyperion project, which you will hear more about in a few moments from Dimitris. Then for Spain, at Valencia Administrative Complex. In Poland, the municipality-owned public kindergarten. In the Netherlands, Hunemint, a social ecological housing project. And in Lithuania, the Vanier Greenhouse project, a renewable energy-based refurbishment of Soviet-style multifamily house. And for Germany and the UK, we're currently identifying the most appropriate pilots, so they will be included as well in the analysis. Next slide, please. So the main conclusions of the model is that it's applicable to a wide variety of situations. It's enough to understand. It provides insights to existing configuration, and it also provides possibilities to analyse the impact of the infrastructure, configuration, modification, as well as the impact on business case outcomes. Next slide, please. Something on Work Package 6, Dissemination and Communication, led by the Energy Saving Trust in the UK. So during the project, we've set up the website, of course. We've had several articles, presentations. We've had many national level dissemination webinars, and also EU dissemination webinars, an example of today. And we had the one on the 1st of July and on the 8th of July. And please follow us on Twitter as well, Twitter @EU Heroes. And there's also a LinkedIn group in EU Heroes. Next slide, please. Something regarding the impact of the project. Regarding the strategic impact, during the course of the project, we've closely been following the Renewable Energy Directive, in particular Article 22, and we're providing recommendations for effective implementation. In fact, we had a whole webinar, which some of you may have attended last week, 2 weeks ago, sorry, which was devoted to policy, and we were happy to have a speaker also from DG ENA, from the European Commission. And we're developing a paper on policy recommendations, which you're also invited to contribute to. And I'd also like to mention that, well, of course, we're delighted we're delighted that energy communities are now included in European legislation. And I wanted also to mention the great collaboration we've had during the course of our project with two related PV projects. So one was PVP for grid, and the other one was iDistributed PV, which you may be familiar with. Both these projects have now come to an end, but we organised a joint policy conference just before the lockdown in November, and another one in February. And we also had a workshop a joint workshop at the Intersolar Conference in Munich, 2018. Regarding the market impact and socio-economic impact, we've contributed to the smooth transition from a subsidised deployment to market conditions, so accelerating the empowerment of citizen engagement with renewable energy. Energy and environmental impact, of course, we've contributed to the increase in share of renewable energy in the EU energy mix. And last but not least, we have shortened the somewhat expensive learning curve, making this energy transition in society possible. I think this whole project demonstrates that it's very valuable exchange of information, and I hope that we will continue to collaborate. We have a very nice collaboration in the group, and I'm sure that we will collaborate in the years to come. Next slide, please. Okay, on that note, I would like to leave you with some concluding remarks. Could it be that there are no more heroes? Could it be that we don't need another hero, or do we? Or could it be that with the right legislation in place, with a level and equal playing field, with increased public acceptance, that we could all be heroes and contribute to a greener, cleaner and brighter future? We believe that the growth in energy communities and citizen engagement in renewable energy will help pave the way towards a zero carbon energy society. So thank you for listening. I think the next slide shows the EU Heroes website. It's very easy to remember, euheroes.eu. Before I pass to the next speaker, I would just like to stress that we invite you all to please come with any questions you may have in the Q&A tab, and we will take up your questions during the discussion. So thank you very much, and I would like to pass the floor to Vitas from Protech, who will tell us about the zero-emission multifamily house in a Lithuanian village. Thank you. Welcome, Vitas.
Yeah, thank you, Rebecca. Do you hear me well?
Loud and clear, Vitas.
Okay, fine, thanks. Yes, and thank you for the opportunity to present some green ideas from Lithuania. They are based on the work done during execution of EU Heroes project. And if we will review the development of PV installations in Europe, we will see that there are very many ground-mounted systems, a huge quantity of roof-mounted systems of private houses and warehouses and industrial buildings. But if we will see on about multifamily houses, there we will find that very rare we'll see PV modules on the roof of such houses. Next slide, please. And there are plenty of such buildings in Europe, but energy supply of such buildings are, we can say, far away from possibilities of this 21st century. But technical and economical achievements opens new possibilities for modernization of such buildings. And what our research made during EU Heroes projects shows that it is a very real possibility to reconstruct, to modernize these buildings for up to zero emission level. Next slide, please. but some conditions have to be for such development. First of all, it is necessary flexible net metering system in the country. But some countries have such, and other base it is effective geothermal aerothermal heat pumps. It's strange that these heat pumps not very popular in middle countries of Europe. They are very popular in northern countries, where they work not so effective, such as in Germany or England or Belgium, but now they are very effective, and it is necessary. It will be very good to use them. Also, green ideas also have to be in the heads of population, because without that, it's difficult to explain. And but usually it concern with communities, and community thinking also is important. Next slide, please. What does it mean, flexibility of net metering system? But in our country, we reached that limit of prosuming can be 500 kilowatts. Usually in most countries, there are 5, 6, 10 kilowatts, and it is understandable because governments, prosumers don't pay all energy taxes, but they implement Green Deal with their money, and I think it is normal that these consumers of electricity which do not participate in green movement, they we can say pay a little CO2 tax. Also very important that in our country officials understood that it is possible to arrange system that you can produce electricity in one place but consume in other place, and this is especially important for multifamily house, because it is impossible to put on the roof of such house 100 to 150 kilowatt power station, because there is not enough space. And it's also was big advantage that in our country open possibility to buy part of big electric power station and use in this house. For example, multifamily community of multifamily house can buy 100 kilowatt in the power stations of 10 megawatts, which is constructed in other part of the country. Next slide, please. Yes, now we decided to take one concrete house and to test our ideas. This house, typical Soviet house, many of them in rural areas of country, but it was successful that community which is arranging this house rather progressive, mainly teachers of local school and chief of community is active and understand energy. But we try to implement these ideas in this house. Next slide. Next slide, please. Now, then here I will present some concrete figures. Maybe it will be interesting for those who will try to compare figures in your country or some house and in our country, to better to understand this project. Not a total area, about 1,000 meters, 20 apartments here. electricity consumption. It is necessary to mention that before project it is less than after project, because solar electricity will be used for heat pump and for producing heat and hot water. But this building will be also, we name that he will be insulated and to make will be make covering. We name as it is as renovation, energy system modernization, and covering or renovation. It is insulation of building. Next slide. But here you can see figures, concrete figures of this project. In our country, 1 kilowatt produce 1,000 kilowatt hours, cost 900. Notice very important direct consumption rate. When you use immediately electricity, you will not pay a net metering costs. Therefore, not in this building was 30 the direct consumption, and 70% you have net meter. No? There are tariffs, our tariffs, 15 cents of electricity and 5 for net metering. Figures of heat pump and heat costs now, which are in this building. Next slide, please. Now, this slide shows that the 75% of cost, it is renovation or installation, and only 20%, no, 25% it is modernization. It's but it is renovation or installation is very not effective system of refurbishing of house, because yes, it decrease energy consumption sufficiently, but it is very high cost of such decreasing. And the same results it is possible to reach via solar energy and via using heat pumps. And in this case, you can refuse renovation and to reach the same results with much lower cost. Next slide, please. Yes, but for that experiment, real experiment and first experiment, we tried and succeeded to explain for a government that it is necessary to make big support, not ordinary support, and for renovation it will be support 30%, and for energy 60%. And results of such experiments are that before modernization, people paid 106 euros per month, and after modernization, they will pay 35 or almost 40% less for energy, and it is included all costs of renovation, of energy modernization, costs of loan. But again, if we will calculate renovation payback period, it is 16 years. There are ideas of passive houses now in Europe, but passive houses reach result, the similar result, if even much higher cost. And there is no reason to calculate payback period, but it is 50-60 years. And energy payback period will be 5 years in this project. Next slide, please. Yes, but as usual, there are obstacles, and there are the first big obstacle that it is so difficult to explain for people what it is solar energy, that it is especially heat pumps, which take heat from weather, and even in -10 temperature, -10 Celsius temperature, you can take from such weather heat and use for a house. No, but it's necessary time and to explain for people. Next obstacle is even companies are they are usually very specialized. There are solar installation companies, yes, very good. There are heat pumps installation companies, but they do not work together. And but here, technical solution have to be integrated solution. It is not easy to find results, and third, it is even from a legal point of view. There are very good legal base for electricity, good legal base for heat, but when you again integrate the system, legal system works very big problem. Next slide, please.
2 more minutes, Vitas.
Yes. Yes. I don't hear you, Rebecca.
Sorry, I said 2 more minutes, and then we move to the next presentation.
Okay, fine. Then conclusions. Yeah, but that we say that this experiment show that economical, technical, very economically, technically effective such project showed that it's helped to collect to one part our communities and to create energy communities, and we are now working that to arrange program that even not only one building would be, that group of building or even small city for with zero emission, and such project now in consideration with our officials. And thank you.
Thank you very much, Vitas.
Yes.
Again, if you have questions for Vitas, please put them in the Q&A tab. We'd like to move now to the presentation by Dimitris, the Vice President of Hyperion Energy Community in Greece. So the floor is yours, Dimitris.
Hello, good morning. Can you hear me?
Yes, we can, loud and clear.
Okay, great. So yes, my name is Dimitris. Apparently, I'm the Vice President of Electra Energy, which I will explain briefly what it is, because it will help you to better understand about our initiative and our energy community that is called Hyperion. So Electra Energy is a social enterprise, a social cooperative that was established in 2016 in Greece, and it is aiming to support the development of the community energy sector in Greece. We are members of RESCOP EU and other federations and organizations. Next slide, please. Yeah, so I think, yeah, you can, yeah. So what we are trying to do, as I have already said, we are trying to raise awareness about the community-based energy production and not only production, but also energy management and energy saving and everything that is related to collective actions associated with clean energy. So we are also doing capacity building advocacy, which is very, very crucial, especially during this time for Greece and for whole Europe. And we are also supporting groups of citizens, municipalities, and other stakeholders that they're willing to implement their own initiatives. Next slide, please. Also, we have coordinated and co-written the first community energy guidebook for Greece, and together with CAPE, that was CAPE Crest, that was about one year ago. Next, please. So the reason that we did that we are actually doing Hyperion, there have been many delays, is to better understand before we really start advising people and local communities on how to do and how to develop community energy projects. We had the idea to develop a prototype collective self-consumption energy community in Athens, Greece, with the participation of people from our organization, from Electra Energy. There are also people from Greenpeace Greece. There are also people from WWF and other people and citizens that are interested to learn more and to practice how an energy community in Greece can be developed and can be operated. Yeah, next slide, please. So yes, next. So the current context, the current context is that, as you are probably already aware, there have been a directive in 2018 about included in the clean energy package, which introduced the term and the concept of energy communities. At the same year, it was transposed to Greek legislation through Law 4513. Sorry. Next slide, please. This is quite a complex diagram. I will not pay much attention to that, but this is our way of thinking. So how we understand the energy community initiatives right now in Greece is like they're niche initiatives that they are trying to be developed and survive in an energy sector and an energy model that has not been designed, obviously, for community energy initiatives and models. So in order to achieve that, developing a prototype is not enough. Having a good law is not enough. Is obviously necessary, but still is not enough. Having people understood what this model sees and having educated citizens is good, but still is not enough. When we have all this group together and matched together, when we have people that are aware of community energy, of the community energy movement, when we have the right legislation in place, when we have the right financing tools, when we have the right technologies to support the administrative issues and the management issues of this kind of initiatives. So when we have all these different pieces matched together, only then we will be able to have a successful community energy models in Greece and all over Europe, I guess. Next slide, please. So in order to test all the above, as I said, we are now developing Hyperion, which is an energy community in Athens. It is based in, it is an energy community, as I said, but it is also based in a virtual net metering model. And Greece, I think, is probably one of the only one country right now that has the this great gift that you can have a virtual net metering model that is collective. I'm not sure that this will last for long, but right now it is existing. And this is what we are trying to test. Next slide, please. So the Hyperion will be based, it includes a photovoltaic installation of 100 kilowatt in phase 1. It is based on virtual net metering, as I said. It is mainly targeted to citizens and households and small SMEs in Athens, Greece, and the Attica region. But the installation point, the actual plant, will be based in a neighbor region, the region of central Greece. Next slide, please. So for those of you that you are not aware how virtual net metering costs, a household can purchase, let's say if you have 180 kilowatt a plant, purchase a household or a citizen can buy a share that corresponds to the to their electricity consumption. So they can buy a share of 3 or 4 kilowatts out of the 100 kilowatt. So instead of having to install a photovoltaic panel in their rooftop, which, as you're probably aware, in Athens and in other urban areas, installing photovoltaics in block of flats is not very easy, especially in Greece. So you can imagine an apartment in the center of Athens that can compare the electricity production of their proportion in the plant with their consumption. So if the consumption is higher than the production, they will only pay the difference. Next slide, please. So here is just a diagram indicating that you can have this collective solar farm, and each panel will belong to different people. Not only households, we also want to test small businesses and SMEs, and also want to try to include some households that are facing energy poverty issues in order to see how we can mitigate and tackle energy poverty issues in urban areas especially. Next slide, please. I think this is the last one. So as I said, the reason that we are doing this is to test the model in a more holistic way. So to test the legislation, to test the relationship between the member and all the socio-cultural aspects of it, to test the technological aspects and the limitations that are currently available, and of course to test and to develop, if necessary, the financing tools, and to work together with organizations like CAPA that are already supporting this, the ministry that we also have a good collaboration with, and other organizations and NGOs in order to test the model and to try to see what are the problems and how to solve them. And of course, the reason we are doing all that is not just to do it and to finish and then that's it, but to expand it and more importantly to replicate it in other places in other regions in Greece, and hopefully maybe in the Balkans region as well. So yeah, the main project targets is to produce clean and affordable energy, obviously, to provide the energy efficiency and energy saving solutions to members, to try to replicate this model. If we do it and it is successful, but it's not replicable, then this is not enough. This is not the reason we are doing it. Of course, to raise awareness and in it has already gained quite a lot of publicity, but we hope that it will gain more publicity in the near future. And of course, to try to develop and test solutions and models that will enable us to mitigate and tackle energy poverty issues. I think that's it. We can go to the next slide. Yeah, so that's all from my side, just to give you a better idea of the progress that we have done so far. We have already established the energy community, I mean the legal status of it. We have done quite a lot of work on raising awareness and informing people and organizations and the ministry and everybody in municipalities about it. We already have 45 members. We will start the actual construction of the plant in November. As I said, this will be the first step of 180 kilowatt, and within 2021 we want to expand it to 500 and then to 1 megawatt. Yes, I think that's all from my side.
Okay, thank you very much, Chris. We look forward to hearing the more developments of the project. Very interesting. I'd like to give the floor to Piotr from KAPA in Poland, who will give us a presentation on PV integration in active housing. The floor is yours, Piotr.
Yes, thank you, Rebecca. Good morning, everybody. My name is Piotr Nowakowski from KAPA, the Polish National Energy Conservation Agency. And today, due to the fact that prosumer sector is actually growing rapidly in Poland, but also due to the fact that prosumer installations are very often key elements of energy communities, I would like to show you a comprehensive analysis of functioning of such installation. So next slide, please. Yes, if we take a look at the numbers, because the Polish sector is booming, as you can see. We have at the end of 2019 we reached more than 1 gigawatt of installed capacity, and now we've reached 2 gigawatts of installed capacity, and this capacity is composed mainly by prosumer installations below 50 kilowatts, but still the share of energy produced by micro installations in Poland is very low. So in comparison to total domestic energy consumption, there is only it's even less than 1%. But the figures speak from themselves, and you can see that this micro scale sector is growing. And at this point, I would like to say that this situation is caused by mainly by change in our national renewable law. And in 2016, we introduced net metering scheme. And last year, we made some amendment to this law, and we made the extension of net metering scheme for small and medium enterprises and for energy communities and for energy cooperatives, to be specific. And previously, this net metering was dedicated only for individuals and for public sector only. So nowadays we have a broad spectrum of actors that can utilize this support scheme, That's why this sector is growing. Next slide, please. Yes, and another very relevant information is that our Polish net metering scheme is not the typical one, because simply saying, if we feed into the grid 100 kilowatt hours, we are able to receive 80 or 70, depends on the capacity of the installation, from the grid without any additional costs. That's the general rule of the scheme. That's why we sometimes use the name of discount system, because this is not a typical net metering scheme. But I would like to present you our model PV installation that we chose within EU Heroes project to deeply analyze it. So as you can see, this is PV installation integrated with passive single family house. What is relevant? This passive house has only one energy carrier, which is electricity, and due to this fact, for heating and cooling purposes, it uses a heat pump. Of course, it's also equipped with mechanical ventilation and heat recovery, which is typical solution for this kind of buildings. But what it's worth to stress out is that the PV installation was designed at the very early stage of the concept of the building. That's why it's the installation is, as you can see on the picture, is well integrated, and the capacity is appropriate to the energy consumption. But we'll talk about this later. And yeah, we can move to the next slide. Yeah, and since October 2016, we are able to monitor basic parameters of the installation. Of course, energy generation, consumption, the amount of electricity that is fed into the local grid, the electricity that is delivered from the grid, and also energy self-consumed. But since August 2018, we are able to monitor additional parameters, which are ambient temperature, PV modules temperature, and irradiation. And based on those parameters, we elaborated our analysis. Yeah, we can move on. So thanks to our Greek colleagues from CRES, because they proposed and elaborated this portfolio of different indicators, technical indicators, and we use these indicators and the data from the last year to calculate all these parameters and perform full assessment of PV system functioning. So we can move to the first parameters. We can move to the next slide. Yeah, this one. So on this slide, we can see energy consumption and PV production, and just on the first look, we can see that energy generation and energy consumption is they are totally incoherent. Of course, energy production is determined by our geographical location our conditions, and energy consumption, especially in the winter months, is very high. Of course, this is due to the fact of higher use of heat pump for heating purposes. But even on this slide, we can see that without net metering scheme, we wouldn't be able to speak about profitability of such investments. And of course, the numbers, energy consumption is relatively high for a single family house, and for that reason, the capacity of PV system had to be equally high. Yeah, we can move on. The next very important parameter, which is self-consumption index, it is defined as a ratio between energy generated and directly consumed by home appliances, divided by the total energy generated by PV system. And of course, if we take a look, the energy self-consumed on annual basis was 24%, which corresponds to 260 kilowatt hours. The rest of the energy was fed into the grid, more than 8,000 kilowatt hours. And this amount of energy was calculated as a discount for 6,500 kilowatt hours. And this amount of energy was received back without any additional costs. And the owner of the installation had to buy almost 600 kilowatt hours for the regular price of the electricity. Yes, the next slide, please. Productivity index. Of course, this graph corresponds to energy production, but is defined as a total energy production related to nominal installed capacity of PV generator. And if we sum all the figures from every month, we'll receive more than 1,100 kilowatt hours per kilowatt per year, which is very good result for PV installation in Polish geographical circumstances, because usually PV installations in Poland can generate around 900, maybe 1,000 kilowatt hours per kilowatt. But in this case, we can see that the performance of the installation is exceptionally high. But we will come to the yes, we can move on. The next slide is capacity utilization index. This is pretty much the same parameter as the previous one, but we divide our energy generated by PV system by energy that would be produced over a specific period in the time of operation with nominal power. So this number 1,100 hours says that for this period the installation worked with nominal capacity during the year. So this is also very high very high value of this parameter in Polish circumstances. The next slide, please. Self-sufficiency index, very interesting and very important parameter, because it says in what extent we are self-sufficient, in what extent we are fully independent. So this average annual value, which is 30%, it says that in 30%, we were able to cover our electricity demand over the year without any use of the grid. But the rest of the electricity, the 70%, had to be received from the local electricity network. Then the next slide, please. Yeah, and if we take a look at the share of energy generated and fed into the energy generated and self-consumed, we can see that only in 1 month, only in January, the volume of energy self-consumed was higher than the volume of energy fed into the local grid. But for the rest months, the volumes of energy fed into the grid are much higher than the volumes of electricity self-consumed, especially in summer months, where the volumes of energy fed into the grid are way greater than self-consumed. So this may lead us to the conclusion that net metering scheme is undeniably needed in case of this micro scale PV installations. Next slide, please.
Your conclusions. I was going to say 2 more minutes.
Only 2 more minutes, because I prepared something else. But all right, we will see. So, a few conclusions. The installation was well developed, and the high quality components were used for the installation. That's why we have such good performance of the installation. And based on our monitoring system, the solar irradiation was exceptionally high in last year, and this is also the main reason of such good performance. Yeah, as I said, the net metering scheme is undeniably needed, and under the net metering scheme, we can design a fully self-sufficient single-family building, as it stated on the bottom. And next slide, please. If we have a second, if we take a look at the profitability of this particular installation, on the top there are some fixed values, but if we take a look on the graph, our profitability of this investment is roughly 9.9, let's say 9 years. But if the capacity of the installation was more than 10 kilowatts, then the simple payback time would be longer. That's why the correct and appropriate design of the capacity is crucial for the final profitability of the investment. Next slide, if I may. I'm just coming to an end. And for this purpose, we can use mathematical formula. We don't need to estimate any values. We just need to know two parameters. We need to know our annual energy demand, and we need to appropriately estimate our self-consumption rate. And if we know those two values, we can correctly calculate the capacity needed in order to be fully self-sufficient, of course, operating under net metering scheme. If we don't have any time, but I would need 2 minutes more if it's possible. Rebecca?
I think we need to the next presentation, Piotr, if that's okay.
Okay, so thank you very much for listening. That's all from my side.
Okay, thank you very much, Piotr. I'd like to give the floor to Dan McCallum from EGNI Cooperative UK. He's director, and he will give a presentation on the portfolio approach to community PV. So Dan, the floor is yours.
Hi, Rebecca. Dan can't be with us, so we're going to skip on to Ben. Are you okay, Ben, to pick up?
Hello.
Hi.
Ben.
Hello.
Hi, Ben.
Oh, so everything went a bit silent for a moment then.
No problem. You're with us.
Great. Okay. And I've lost a toolbar, so I would happily share my grisly face, but I can't at the moment. I don't have the button for it. So yeah, thanks for inviting me to speak to everyone today. I'm a development manager with the Energy Saving Trust. I've been working with community renewables one way or another for about the last decade, and it's good to see some familiar faces actually from a session I joined in with EU Heroes a couple of years ago at Specific in Swansea. It's great to see the project progressing. So since then, I've been part of this project called the Green Valley Lines, which was a feasibility study that was undertaken during most of last year to identify the optimal technology mix. This was to allow the South Wales electrified traction system on the railway to run fossil-free in the future. So we wanted to see how we could provide direct traction power supply from community-owned renewable electricity generators together with integrated energy storage, and that was really to reduce both the environmental and the economic costs, if we could, of providing traction power to those lines against a business as usual baseline. So if I could have the next slide, please. So the map in this slide, that just you can see Cardiff, the capital city of Wales, down in the southeast corner or side of the ellipse there, and the network of valley lines, the core valley lines, moving up to the north and west. These are branch lines which have served valleys, communities that have historically been supported economically by mining. They're now pretty much dependent on Cardiff for a lot of jobs as well as shops and services, so they're quite heavily used lines. You've also seen on the slide the range of project partners, so two major funders, the Rail Standards and Safety Board, the UK Research Initiative, Innovate UK, and then we had obviously Network Rail and Transport for Wales as partners from the rail side. The project was led by Riding Sunbeams, which is a community interest company. It was formed largely by work between Community Energy England and the campaigning charity 1010, campaigning against climate change. And then you have a range of technical partners, of whom the key ones were Energy Saving Trust and Ricardo Energy and Environment. If we have the next slide, please. So just to give a bit of background, the whole story begins really with the constraint on the transmission and distribution network in the UK. So you have the community in Balcombe campaigning against fracking, but feeling that they should put some solar PV in to show that they are pro clean energy, but unable to afford a connection, and looking at their railway, asking could the rail electrical network be utilised more fully by renewables, and would that create a lower cost route to market for community renewable generation? So you have two reports on this slide. The first on the left identified that there was certainly a huge opportunity to sell power directly to the rail network, and that we could avoid using the UK transmission and distribution networks on the whole. And that's because Network Rail does actually hold its own license to operate an electrical network for traction and trackside power. And that is supplied through grid supply points along the rail network from the wider distribution and transmission networks. So this ability to run a network does allow for some unavoidable spill, which largely comes from peaks in regenerative braking on vehicles. That goes back onto the UK grid, but the license doesn't formally extend to an ability to systematically sell export power from the rail network back onto the UK grid, and that's really a regulatory rather than a technical barrier. So anyway, the first report identified different electrical engineering solutions for supplying power to the two different types of networks, which are high AC networks or low DC voltage traction systems. The low DC voltage is typically subways, tube trains, what you would know as third rail on the ground, with the high AC being overhead wires. So the second report was first of a kind funding to connect to a low voltage network, and that focus on low voltage actually arose because the plug-in points, the grid supply points, are more frequent on low voltage systems. So it was easier to find sites that were very close to the railway and that were very close to a plug-in point. That said, it was known already at the time that the high voltage technology was a much more widely used one. Nobody really builds low voltage rail any longer. So it was a very important opportunity to go on and try. But that second image, that report from Aldershot, is now a functioning 100 kilowatt test connection, which is running and delivering renewables directly to rail traction today. So next slide, please. We had some quite helpful drivers, policy drivers behind us in taking the project forward. They've certainly been added to by the adoption of climate emergency declarations by a lot of governments and local authorities, Welsh Government included. But Welsh Government also has some key targets under the main policy, the Act, the Wellbeing of Future Generations Act. That's driven targets for renewable energy generation. We've got a target to have 1 gigawatt of renewable energy generation in local ownership by 2025. And from this year, 2020, all new energy projects in Wales must have at least an element of local ownership, even if they're developed by commercial and external developers. There's a new contract for the Wales and Borders rail operation franchise that was awarded to Keolis Amy in 2019, and that had really stringent expectations on driving down the carbon dioxide emissions and on local procurement of the energy to do that across the Welsh rail network. So they're looking for net zero emissions across all franchise operations by 2030, but they're also looking for 50% of the traction load to be met by Welsh generated renewable power by 2025. That's very helpful to us. So the funding that we got was consistent with UK government objectives around the rail industry. And in that light, we did consider a report that included carbon pricing as a possible driver. But in the event, we think that we can make this economically viable without using a carbon pricing lever. So next slide, please. So this slide really just shows one graphic that describes the different electrical line sections and identifies the grid supply points, which on this slide are marked Upper Boat GSP and Imperial Park GSP. So these are high voltage connections from the electrical network, the wider distribution or transmission network, in fact, in both cases here. And the Upper Boat one connects purely back and forth in the middle of the sort of mess of the Valley Line's branches, whereas the Imperial Park one is also connected to the main line back to London. So that's been very helpful for us because we were able to model to pass through spilled electricity from the Valley Lines connected to the Imperial Park GSP, and we were allowed to spill that directly back onto the main line. So we have 100% utilization there with a very busy main line. So the aspiration of the project was to co-design some engineering solutions, which were a detailed interface design to match the load profiles to the generation and storage opportunities, and to identify some real life generation opportunities on the ground. So that was largely an EST task by resource mapping through GIS and some planning policy analysis to see what were viable sites close enough to the rail and capable of supplying cost-effective low-carbon traction power. So the outputs from the project were intended to provide some resources and intelligence to the wider rail industry. So that's for global scaling up and also to have a portfolio of sites that we could take forward on the ground towards an implementation phase on the Green Valley Lines. Next slide, please. So I've just described a very well laid plan, but the best laid plans of mice and men, as we know, don't always work out. So I'm not going to read through the content on this slide, but as you can see, we had a range of challenges, all of which we found useful responses for, and we really did that by iterating most of the work streams fairly repeatedly as each work stream came up with different challenges to our original assumptions. Assumptions being broken and new solutions proposed. But we did have some good surprises in there, along with the less helpful news. So the grid supply point at Imperial Park, for example, was one of them. And ultimately, we evolved this into a fairly detailed set of assumptions and sensitivities, which we then took to test to take through some financial tests. So the next slide, please. These figures are indicative really of the method that we used and the data that we took account of in doing the modelling. They're a little bit out of date now, and we've been iterating the model further. But fundamentally, what we wanted to discover was how small we could get sites to be economically viable, how close they had to be to the railway. We had a serious issue with the cost of the conversion technology, which was really made the whole project completely non-viable. There are converters available on the market at a cost of about £1,000 per kilowatt. They're an awful lot more sophisticated than what we need to deliver the project, and we certainly need to get a lower price point for them. But then we set some benchmarks for an IRR of a minimum of 5% and a debt service cover ratio minimum 1.2% to test what projects we thought we might actually be able to build. This is just for solar. We did look at wind turbine projects as well, and it has to be said that we were really surprised, but wind was in fact a lot more viable than we imagined, and it's quite a lot more flexible and easy to deliver in terms of the economics to the rail network. It still presents quite a lot more barriers in terms of the planning applications, certainly. But we also found that deploying mixed technologies would maximize the overall contribution to decarbonizing the traction. And out of that exercise, we were able to start matching our financial constraints against the projects from our GIS exercise that remained viable in the light of the financial testing. So this is quite, again, a bit out of date, quite high level, but as you can see, we could meet a significant part of the TFW target of 50% traction power quite easily. In fact, we can exceed it as long as we can refine the generation against the headroom on the line capacity, which is a really key constraint. So the overhead lines typically have a limit of 10 megawatts AC, which we've modeled to max out at around 12.5 megawatts DC generation. So we certainly need to refine the modeling from that. That wasn't part of the task of this feasibility, but having real on the ground projects will give us the opportunity, we hope, to refine that, get the best technology mix and maximize the connections that we can make. Next slide, please. So we identified some conditions that have to be met. It's unavoidable that we will end up with some spill or some curtailment from the generators on any line section that we looked at. And we looked at line sections with quite different levels of utilization and quite different rail timetables. So really, we need the rail electrical network license to allow to absorb spill on either a standard or a sleeve PPA out onto the grid in order to avoid the cost of battery storage, because we really found that battery storage at the moment remains too expensive to make this project work. And just to iterate again the point about the converters, so you can pull one off the top of an existing rail vehicle if you can find a rolling stock company that will allow you to do that, which we haven't. But that's a much more sophisticated piece of kit that does more than we want. So we think we can achieve, and there's a project underway now to achieve a lower price point for the converters. Next slide, please. So really, these are what we found as the key outcomes of the projects. We have a technical solution. We can inject renewable power generation directly to the AC rail networks. That turned out to be remarkably simple, and we didn't have the constraint that we thought around the grid supply points. We can simply build a gantry wherever we need to at a cost of about £100,000 and a small compound to really just deal with the conversion and earthing issues from a private wire. We've defined the regulatory and market barriers to deploying the solution, and we've demonstrated that we can get economical viability and significant carbon savings with that route to market. And we can also take a lot of pressure off the UK grid network by making much better use of what's frankly quite an underused resource on the rail traction network. We've provided this methodology. We know pretty well how to refine sites and test their viability and to identify the right scale and the right type of generation to connect to any given line and timetable. And if the market conditions and regulatory conditions can be corrected and we can get the converter at the right price point, then we can certainly meet Transport for Wales's decarbonisation objectives. And we can offer alongside that a long-term low-cost price of energy, we think around 8p per kilowatt hour over a long-term PPA is probably the sort of offer that we're expecting to make to Transport for Wales by the end of this summer. And that is all the slides that I've got to present. Is that the next one, I think, is just a thank you. Oh, there's a next steps. Apologies. We've got some next steps, some of which are in train already. So since I wrote these, we've actually, Riding Sunbeams have received the first of a kind funding for developing the converter. And we're quite confident that we're going to achieve a price point below £100 per kilowatt. So that's 10% of the existing cost of the existing market solution. And the intention is to start looking by the end of the year at which sites we'll prioritise for development under a business model that will provide 51% of ownership to Wales-based community organisations and the other 49% to Riding Sunbeams, which in any case is a community interest company. So it's a really high value project for communities. I think that's me. Thank you very much for listening and for your time.
Okay, thank you very much, Ben. I suggest we now break for coffee. So we're going to take a 10-minute break. I hope that's okay with everybody. So we will reconvene at 12:10. Okay, see you in a bit. Back, everybody, the coffee break. We'd like to now continue with session 2, so building on the momentum. So during this session, we'll be presenting perspectives on the short, medium and longer term opportunities for PV in the respective countries of the EU Heroes project. But before we go into that discussion, I suggest we just take up a couple of questions that came up in the Q&A. So if I just give the floor to Graham to pick up on those, if that's okay.
Thanks, Rebecca. Yeah, so we have a couple of questions. We've got one to Vitas, who has actually left, which was asking what experience from the EU Heroes project was useful to your pilot project. I think unless anyone has any immediate answers to that, maybe we could perhaps all bear that in mind and perhaps comment on it when we're talking about the immediate opportunities for community PV, because we can kind of give the examples of how we've worked with pilot projects. So there's also then a question to Piotr, which he has answered in the text, but I don't know if you wanted to say a quick word about that, which is the heat pump activated when the PV is producing for demand side management?
Yes, Graham. As I wrote, there is no such correlation between heat pump and PV system, but such solution of demand side management could of course increase self-consumption rate of the energy produced, and in the end it could improve economic profitability of the investment.
Thanks, that's great. And then we also have a question for Demetrius. I think Demetrius has gone, but I'm not sure whether anyone else can answer this, which is good to learn about electro energy. Could you elaborate on how you cooperate with municipalities in promoting community energy activities? Do you see barriers for local governments in taking up a facilitator stroke promoter role? Is there maybe anyone from CRES who could comment on that? Or if not, maybe it's a question that we could kind of pick up in the wider discussion, because I know it's something that we've looked at in the UK. So we actually did some work a few years ago now with a municipality in Wales, with Swansea, which because they wanted to actually set up a community solar project that was specifically going to be in deprived wards, within deprived areas within the city, and they wanted to do that in an inclusive way and make sure that the community-owned solar was putting benefits back into that community, so the surpluses were going back into kind of job creation and training, and worked through them with a number of different ways to do that. And that was a really interesting process, because it did kind of illustrate that there are a lot of opportunities for partnerships between municipalities and energy communities, where, you know, in some cases, if the municipality is starved of capital, that they can potentially partner with an energy community to actually deliver renewables that they might have aspirations to do. Or in some cases, you know, it might be that the municipality could be the catalyst that helps to set up energy communities to deliver things, or perhaps even, you know, there are examples where municipalities are actually setting up a separate kind of social enterprise to run an energy community. So it is controlled by the local authority, but still has the opportunity for local people to kind of buy in and get benefit from it. So unless anyone else had any comments on any of that, I think that's the last of the questions that we have in the Q&A panel, but please do feel free to post more in there if it's useful. So we had a couple of framing questions to just kind of kick off the discussion, but anyone at all who's listening in, please do feel free to put comments and questions in that Q&A panel, and we can pick those up as we go. But the first of the questions that we had was, what do you think are the key opportunities for community PV in 2020? And I think we were going to go around the table, weren't we, Rebecca, and get a comment from everybody?
Yes, that's right, Graham. So I suggest that we start with Chris, if that's okay. So if you could provide your answer to what do you think are the key opportunities for community PV in 2020? So Tassos or Vangelis?
Can you listen?
Yes.
It's okay. So hello everybody. I'm Vasilis Kilias, and I attend this interesting webinar with Tassos Kiritsis. So we're both present. And first of all, thank you for the invitation. I'm very glad that I participate in this discussion, especially after lockdown. You know, even still until February, we had a very vast plan of visiting municipalities and working on with energy communities, especially in local governments. But after the lockdown, then we stopped working on that. We stopped communicating. We started discussion by, let's say, the social media or webinars. And this is a good time to start again by spreading our efforts on energy communities. So I'm very glad that we start again by discussing in EU Heroes your outcomes. So first of all, I think Graham had posted a very important question to Dimitris Kitsikopoulos. I think Dimitris is not here. And Graham mentioned the role of local authorities, of municipalities on the acceleration of the development of energy communities. So my first idea is that local governments and municipalities, first of all, need to elaborate and implement their own energy communities. In this regard, especially under the Greek law for energy communities, then it's very easy for the municipalities to work together with other, let's say, private or public bodies in the area in order to conclude to some good projects. So if municipalities work together at a regional level and finalize some good business and development schemes, in any case, especially in production from PV or net metering and so on, then they would they would gain the experience, and after that, they could act as a facilitators too. So first of all, we need to attract municipalities in order to participate in energy communities, and after that, to invite them to act as facilitators and promoters. I think both these roles need to be accelerated. This is an experience from Greece. And we are now in this direction. One very interesting conclusion was made by Rebecca by the end of the speech. Then he mentioned that we need three things. First, legislation. Second, playing fields. And third, acceptance. I think that that would be our final outcome of the discussion. However, we need to work on all these areas. First of all, we need to, let's say, motivate people, and we need to perform campaigns in order to attract citizens and small and medium enterprises to conclude some good business models. It's a long way to go until we have good results on that, because it is not very easy to attract people and also to attract small and mid this idea. Second, we need to make this paradigm, this business model, we need to make it understandable by the others. And what I mean by others is, first of all, the financial institutions. And financial institutions need to adapt their products, their loans, their financing mechanisms in order to be compatible with this business model that we develop. It is not so easy for them to understand what this business model is. They produce, some crazy people produce electricity from PV, and at the same time they consume it, and possibly they sell some services to the network. It's not very easy from a financial point of view to be understood by a conservative financial institution. And the third part would be to prepare an ecosystem of communities, of energy associations, in order to provide a high-level collaboration among them. This third step would ensure that the results would be positive. Without this ecosystem, including municipalities that have already participated and have experience on energy communities, citizens that have this experience, small and medium enterprises, financial institutions, public or private, that have this experience. That if we don't build this ecosystem, then I think we cannot have the, let's say, a multiplication event. So speaking about 2030, then I think that our main target would be not to quantitate how many megawatts might be developed by, let's say, energy communities, but to provide with good steps, with an alternative paradigm, with an alternative business model that might be attractive. So that would be the base target for 2030. I don't know if I have other things to say, but I think that the discussion is very, very, very helpful. Possibly it's good to have good, let's say, best practices more than we have discussed today. It's very interesting that I heard some best practices, especially from Lithuania, for this block of flats that has developed an energy community to produce electricity connected with zero or positive energy buildings. And that's a very, very, very interesting example from Wales, from UK, I think, concerning the railway production, the railway production consumption from PV. So this small part from me now, then we were available in order to discuss next minutes.
Okay, thank you very much, Vasilis from CRES. Shall we move to Protect to Lithuania? Feel free to take up all the questions or just one.
Okay, Juras Urbikas. I'm replacing Vitas, who has some other duties. Well, let's say, talking about Lithuania, is it normal? Do you hear me? Is it okay?
Yes, we can hear you.
Yeah,
There was
okay,
interference, but it's stopped now, so we can hear you.
Okay, great. Well, let's say, maybe Vitas not mentioned, but for Lithuania, we have, let's say, law for PV community or energy communities available just for some days, not months, not years. Therefore, well, it is just a starting point for community businesses. But for prosumers, when you are generating and consuming with net metering scheme, there are already some experiences through Lithuania, and they are quite positive. If thinking in terms of key opportunities and vision for community, you need to understand that Lithuania, with its mentality, Lithuanian people are coming from Soviet time, when this community time activities, which are mainly associated in European heads by kolkhoz mentality, is, let's say, have let's say very clear opposition in our heads. Therefore, to overcome this position and to move into normal community without some kind of slavery, it is a long way for us. But talking about future, you need to understand that another very sensitive point for Lithuania is energy independence. Actually, we are coming out of Soviet system, which is fully dependent on Russia-based electricity. Now we are becoming more or less independent and moving into, let's say, change from Russian-based grid connections to European-based grid connections. And taking responsibility for energy generation into our hands, it's really a serious challenge and one of main priorities, top priorities for our policy. Therefore, vision for community in 2030, I would say it is strong contribution to energy independence of Lithuania and availability of generation power in, let's say, our national environment. How we will manage to get from the starting point to vision of 2030? I think it's by example. This example, which was demonstrated by Vitas, is really very attractive for Lithuania, because there are a huge number of such buildings through households through Lithuania. When you are owning only flat in multifamily house, and the only way to take energy power in your hands, it is creating community for this particular building, or let's say small district level local energy structures. Well, I think it will work. I'm optimistic in this point. Actually, it is what we needed to have, let's say, possibility to see how we are generating and consuming energy, not dealing with big energy players which were not very transparent in previous years. Okay, this is more or less my opinion, my vision.
Okay, thank you very much, Juras. Shall we move to the Netherlands? Vido, the floor is yours.
Yes, I'm in. Hello. Yeah, I would like to start with key opportunities for the PV community PV in 2020 yet. Well, I think the drivers for people to come to communities, we examined it for solar PV, but I think it's more basic what is driving them. I think a community is able to provide a non-polluting, affordable energy resource. I think it provides some social commitment, some social structure. I think it is made available that they contribute to items as global warming. And I think that are more prominent drivers why where people are thinking of joining a community. And I think that is the more important key opportunities of community PV. My vision for the community PV in 2030, I hope that each town from about 10,000 inhabitants has one or more energy communities. And if you calculate on that base, I do believe in the Netherlands we already are there with some 500 communities already existing, not only PV, but all sorts of energy communities. And well, to come to that vision, well, I heard it several times. I think we should do more dissemination. We should support more on a local or regional, perhaps national level, communities or people who are trying to make communities to assist them with tools, to assist them with consoles, with good examples. And I believe from Greece we already heard that the way of doing it. I think that's the most promising way of getting communities to start and to help to find their way to a good business situation. That I would like to attribute. Thank you.
Thank you, Vido. How about the situation in Germany here?
Yes, hi. It's well for Germany or just in general the opportunities for community PV are pretty much along the lines what everyone else has already said here as well. It basically helps to reach the energy transition and climate change goals that we all have. Another important factor is that it makes the energy transition more inclusive, and it allows for every citizen to participate and contribute to fight climate change and to reach the energy transition goals. And by being part of this, by being part of a community, it certainly also has, like Tasso said before, it affects acceptance, and it can definitely increase acceptance for renewable energies or for the energy transition in general. And then ultimately what it also helps with, and what it has already started to do or done, is it helps with driving innovation in this field forward. And so if you look at what's currently happening with the crisis we're going through in 2020, and I think people are starting to realize that they can take matters into their own hands, and that they do have some power in changing the status quo and in changing things. And community PV is one of the ways that people can become part of a solution, rather than just feeling maybe sometimes a little bit helpless when facing all the different crises that we're going through, starting with COVID and leading on to the climate crisis. And then what we've also seen is quite a bit of innovation happening around this as well. So it's actually an inspiration for founders and for startups to find solutions that help to increase the share of renewables, that help to find new solutions and business models around community solar, whether it be collective self-supply solutions or energy sharing within a cooperative or community, or peer-to-peer trading. There are a lot of really interesting and exciting business models coming out of that, attracting young and innovative startups to also participate in this, and finding solutions that make it more attractive for every single citizen to participate as well. Now in Germany, community solar or community energy in general has been around for quite a while. But now it's really all about making the next step and integrating, or have the system integration of PV, and to integrate members or different stakeholders of the communities and cooperatives via these different instruments that are also already addressed in the clean energy package. And the problem in Germany a little bit is that up until now, the regulatory framework does not always necessarily incentivize the collective use of locally generated energy or electricity. So there's certainly some room for improvement here in terms of adjusting taxes and levies that will help push community PV, and especially storage and on-site consumption and energy self-sufficiency forward by quite a bit. Yeah, so this is sort of what we need to look at in the immediate future to then increase the share of community PV even more, and ultimately it would be great to use every rooftop that is available in urban and rural areas for some sort of community solar application. And we have a potential of up around of about 56 gigawatt peak in Germany, rooftop solar. So a vision would certainly be to use as much as possible of this opportunity, and to generate, store and consume more electricity locally, and to make it as inclusive as possible to get everyone on board and be part of it.
Thank you very much, Pia. I'd like to give the floor to Andrea from Carrera, Spain. She was experiencing some technical problems. I hope you're able to connect now, Andrea. Okay, I'm sorry about that. I think Andrea is still experiencing some technical problems there. If you are still online, Andrea, and you would like to participate in the discussion, perhaps you could put something in the chat, in the Q&A. Thank you. And yeah, so let's move to Kapa, Poland. Piotr, floor is yours.
Yes, thank you, Rebecca. Speaking about key opportunities for community PV, at present, I would like to start with saying that it depends on the maturity of the PV sector and the level of the development, because this level of maturity usually defines our opportunities. Eligible business models and so on. And in Poland, we started our energy transition, let's say, in this sector from prosumer segments, and in 2016, and parallelly to this prosumer sector, we've been developing big-scale PV installations through tendering scheme, auction system, and that's why this and we strongly have been supporting especially prosumer sector. That's why is on the top at the moment. That's why it's growing, but also we are standing in front of energy transition, and we need to transpose in our national law some provisions from renewable directive, and that's why our ministry is trying to develop at the moment respective regulatory framework for collective prosumers. So the government sees that this is also the area that needs to be developed in the near future, but regarding to this energy transition and this new business models for energy communities and for individuals, we need to. I think there is a lot of work to inform people about their rights regarding energy management, because most of people do not know that they have even right to change energy supplier, and moreover they have rights to share, to store electricity, and we need to change this perception of individuals and public authorities, enterprises, other entities, and if we increase this level of social acceptance and this perception, I think that it can lead us to new structures, new energy communities, because at the moment, let's say, energy communities were introduced into our national law last year, and they can use net metering scheme on the very similar conditions as prosumers, but there are also other obstacles that they are stopping this kind of initiatives, and we are struggling at the moment. So there is also in the perspective of 2030, there is also a lot of work on the regulatory framework that needs to be done, because we need to create a favorable condition in order to strengthen the power of this kind of initiatives and to mobilize people to create such communities. And there is also an issue with multifamily buildings in Poland, because they can, of course, install PV systems on the roofs, but they can only use this electricity for common areas of the buildings. For instance, elevators, common lighting space, and so on. But this is the current situation is caused by the maturity of our market, but I believe that in coming years we will develop more and more space for energy communities, and more business models will be available for many actors. And I would like to also add that this net metering scheme that is very much developed and used in Poland nowadays, it is designed for 15 years. So each prosumer can use this net metering scheme for a period no longer than 15 years. And after this year, I believe that this is a space and an opportunity for battery storage systems to step in and take over the task of the grid. And this situation also creates opportunities for collective prosumers, and they may also step in and sort of involve those, let's say, old prosumers into new structures, into energy communities. So yeah, I think that this is our future. Thank you.
Thank you, Piotr. And now, Energy Saving Trust UK. The floor is yours.
Thanks, Rebecca. So I'm going to just give a very quick introduction, and then I might just ask Paul to make a couple of comments about the projects that we've been working with. So thinking about the immediate opportunities, certainly for us in the UK, it's around on-site provision, so roof-mounted, community-owned PV, but with a power purchase agreement to provide on-site energy supply. And there are various energy communities that are working on this already. We think there's real opportunities if the public sector could kind of really take advantage of this opportunity, because they have targets to deliver on renewable energy and on carbon savings. And so, you know, if they would start to say, actually, yes, we will host community PV, it might help to their capital budgets because somebody else is installing, but it also then helps to get loads more social benefit out because it's a citizen-owned PV system. You heard a little bit from Ben earlier about the opportunity with connecting to electric rail, which is probably a kind of medium-term opportunity, but a really good example of one of the areas where you can build from that model of roof-mounted power purchase agreements through to, you know, potentially much larger things. So I don't know, Paul, if you wanted to just make a couple of comments. Paul has been working with EGNI Co-op, which and they're working on roof-mounted PV with power purchase agreements, and they've got a kind of portfolio of projects that they're developing.
Thanks, Graham. Yes, I'm not going to display myself this morning, but I do have a couple of thoughts on the presentation that Dan would have given had he been able to join us this morning. Just to reiterate what Graham just outlined as the opportunity areas, I think from the UK perspective in the short term, I guess there are sort of three main challenges for us. One in common with practically everywhere at the moment is how we respond to the COVID challenge and re-energize the economy post-COVID. That's going to be a big challenge, and obviously we're waiting to hear in the UK exactly the detail of from central government as to what the new stimulus packages are going to mean for renewables alongside energy efficiency and other measures. But I suppose on the if you like, the pre-existing opportunities, the climate emergency position of many local authorities has been a pretty strong stimulus for many community groups, alongside the change in the change that is impending in our electricity infrastructure. So we have a massive challenge coming, again, probably in common with many other parts of the world, but in particular, we have challenges as so much of our heating requirement in the UK is based on natural gas, which we don't have unlimited supplies of, evidently. And also we're transitioning to electric vehicles. So that increase in demand for electric vehicle charging and heating through electrical energy, for example, heat pumps, is going to place massive strains on our energy infrastructure. So there is an opportunity really for communities to help efficient network asset management, potentially helping with the distribution supply operators to avoid massive reworking or quite so massive reworking of the distribution networks. But I think what we're facing is really the need for partnership. And I just want to pull up this slide, which is one of the ones that Dan was to have presented, which really sort of highlights three key areas that I think many community groups in the UK are facing since the cessation of the feed-in tariff. So part of the reason Dan unfortunately can't be with us today is that as COVID hit, the feed-in tariff installation deadline for community groups was about 2 weeks away, and many groups had to curtail their installation programs. The government thankfully did extend the installation deadline to September now, so things have restarted as sites are able to operate again. Dan's actually out on site today, meeting with the installation on one of the major projects that the EGNI have been operating on, struggling to get in before the feed-in tariff deadline, which is a 500 kilowatt installation on the velodrome in Newport in South Wales. And that in itself is an interesting project in its own right, but I think more interesting is the approach that EGNI and Newport City Council, alongside a number of other South Wales councils, including Swansea, Cardiff and Pembrokeshire County Council, is to look at a partnership-based approach for supporting the community energy sector. And this partnership approach, as Dan's highlighted in this slide here, is really sort of fundamental, I think, to community projects viability moving forward. I think the symbiotic relationship, really, public sector, as Graham mentioned, are looking to achieve their climate responsibility objectives alongside future generations responsibilities, particularly in Wales, and perhaps stronger procurement requirements around clean energy. We're certainly not at a point just yet where subsidy-free solar is a given. The model that EGNI are looking at is basically along a PPA approach, based on the existing electricity price that the councils and the users would be paying for their current electricity supply. And obviously, as energy prices potentially can go down as well as up, as we've seen in the short term recently, hopefully that will become much more stable in future. But the mechanisms of subsidy-free solar and PPA structuring in particular is one area that needs to be established. Clearly, as we've heard from Pia and others, there's a very significant need for sites that have got high on-site consumption, so that we can achieve the self-consumption rates that we're looking for. That certainly improves the financial viability and the pilot models that we're looking at as part of this project, that is one of the considerations that we're certainly struggling with, is how to achieve high enough self-consumption in order to make the viability of the projects work in the UK environment. And I suppose the third point that Dan was looking to raise is the partnership within the community itself. So learning by experience, sharing of knowledge, exactly as this project is aiming to achieve, but potentially also looking for elements such as joint procurement of equipment to reduce purchase costs. There's a raft of areas that we're going to need to work on, but certainly partnership, leadership, champions. This is all fundamental to how we're going to see the UK sector development, and hopefully we can continue to maintain some of the good work that the European Union has been striving for under the Renewable Energy Directive in our own policy environment. I've said too much, so I will stop there. And Graham, if you would like to jump back in.
Thanks, Paul. That's great. I'm conscious of time. Did we want to wrap up? I do have a comment I could make on the 2030 vision, if it's helpful.
Yeah, I think make your point on the 2030 vision, and then we'll do.
Sure. So I kind of agree with a lot of what everyone else has said. So I'm going to take a slightly different tack on this and try and think a bit about what it might be like from a customer's perspective. So in 2030, I would like to be buying my energy from a local energy community, a citizen-owned cooperative that sources my electricity from a PV farm with co-located storage, which they own. I've also sourced the PV on my roof and the heat pump that heats my house from them. They facilitated that for me, and I'm paying that back on my energy bills. We're now a one-car family because we use the EV car club that they also run, and I get paid for flexibility services. So a really nice, simple, I get paid to do the right thing, and they do the complicated bit of trading the flexibility of that arises from my smart EV charger and my smart appliances in the home. I'm also a shareholder in that, so I get to go to the AGMs. I deal with a real live person because it's a locally based co-op when I have problems, and the cooperative reinvests its surpluses in tackling fuel poverty, reducing carbon emissions, improving biodiversity, and tackling social issues. And they also have special tariffs for people on low incomes to help make energy more affordable for them. So I think obviously that's a bit of an extreme example that perhaps needs music playing in the background and things, but I think it is achievable, certainly to deliver some, if not all, of those things. And you've heard earlier on today from Demetrius and others who are actually working towards some of those things right now. And I think that's the things that we've been thinking about in the policy recommendations that we're working on, is how can we take advantage of the opportunities now and move and build the capacity of this sector to actually be able to move towards that future. So in future, could energy communities have a huge role in actually being the interface between us as citizens and our energy systems, and kind of be our representatives within that system as well. So that was it. That was my thought on 2030.
Okay, I really like your vision, Graham. I think it demonstrates a real hero, and I hope it can be replicated throughout the whole of Europe. I'm conscious of the time, so I think we'll do the wrap up, and please feel free to chip in, Graham, if I miss anything. First of all, I'd really like to thank everybody for their participation and your patience today, and especially the speakers and the panelists for the discussion. Thank you very much. And I think we've seen from the discussions today that there is no one solution. It's a kind of jigsaw puzzle in the whole of the world, really, with different. There's no one energy community. They're very different in each country due to different cultural situations, like we've seen in Lithuania, with different climates as well. But I think through the EU Heroes project, I think we've achieved a lot during the project through this very valuable exchange of information and best practice. But we recognise, of course, that there's much more to be done. We see that solar PV is growing fast, but not fast enough. And as Pia mentioned, there's the opportunity with all the roof space that's still available. Why not use it and put solar panels where, yeah, on more roofs. Also, I think we've heard today that we can do more on dissemination, more on a local and regional level, and we can assist people more in setting up energy communities, provide them with the right tools, and not only that, but also inform them of their rights and the benefits. Let them realise how it could benefit their life and help them to reduce their energy bills, and also contribute to the energy transition. So on that note, I would like to remind you that all the presentations are available on our website. And again, thank you very much. And I think we can all agree that energy communities are continuing to play an increasingly important role in delivering a smart, flexible, zero carbon future. Graham, did you want to add any last final words?
I think you covered everything very well. Just to say, yes, all the findings from the project will be posted on the EU Heroes website, as well as details of the webinars and recordings. And if you follow us on Twitter at EU Heroes, then you'll also pick up news there, including today, there are some new photos of the Velodrome PV installation that have gone up there, and a bit of information about that. Thanks.
Great, thanks for that, Graham. And thanks again to our team at EST for making this these webinars possible. So yeah, I wish you all a good afternoon, and thank you again for your participation.
Thank you, Rebecca. Thank you, Graham.